Okay, so exocrine, endocrine. So endo, we said means what?
Bloodstream.
Or what does this word endo mean?
Or inside the body.
Inside, and then exo means.
Outside.
So a really easy way to think about these guys with all these different things you will know right now. Okay, so esophagus, stomach, duodenum, pancreas, pancreatic duct, common bowel duct, gallbladder, liver, okay? So let's think about this. If it comes from the pancreas, the stomach, the gallbladder, or the liver, it's exocrine. The only exception is the beta cells into the pancreas.
What do those cells do?
The beta cells react to the K cells in the duodenum. Okay, so the other rule is if it comes from the duodenum in the crypts, it's going to be endocrine, because if you think about it, this S cell right here is releasing secretin. And this secretin has to travel up to the stomach. Do you think it swims up through the chyme? No, yeah. The blood vessels travel up and deliver to the stomach. And the blood vessels travel over to this to release bicarb, right?
Yeah, so the secretin when it goes to the stomach, that was just telling it to decrease the motility.
It tells it to slow down peristalsis.
Okay.
And so S, I, and K cells are all endocrine, right? Because those have to travel up to here, and over here, and up to here, and up to here, and over here, right? And so those are all that, right? Like GIP, that's gonna be a hormone.
What does GIP stand for?
Gastroinhibitory peptide,
Okay.
right? I cells, right? What are those gonna be? That releases CCK, cholecystokinin, right? And then you got secretin, right? Those are all going through the blood, so those are gonna be hormones, okay? They're in the blood, and then these guys are going right into this open air, duodenum. This is open to the air, technically, out if that was open down there, right? And so that's very exocrine. So just think, pancreas, stomach, gallbladder, liver, anything that has to go in there ends in an ACE or whatever it is. Bile, doesn't ACE, but still exocrine, right?
Yeah.
These guys, anything in a crypt in the duodenum is going to be endocrine.
Okay. So, as well as beta, which is the beta ones.
The beta cells react to K, which gets activated by what?
GIP, the gastro.
GIP is what the hormone it sends out, but what activates it to release GIP?
The low pH.
No.
No.
That's this guy,
That's
remember?
secretin. Secretin does the low pH. ICCK does all the breaking down. K does lipid, fat, digest.
I does different things, right? So what does I releases all those enzymes to break down the lipids and fats. So lipids and fats and cholesterol activate I cells.
Yeah.
Because they release lipase and amylase and protease. And so they want to be activated when fats get into the play here. But K cells get activated when there's, what is this? It's a carbohydrate, right? Remember that from 264, the long chains of carbon?
Okay.
And they had all these on them. Remember that?
Yeah.
Kinda, maybe.
I'm just wondering why I'm forgetting what the K cells do.
So K cells get activated by carbs.
Carbs.
So just think K kind of sounds like a C.
Carbs. Okay, so K, carbs. Oh, and then.
And then this is your lipids,
Okay.
your cholesterol, and fatty acids, and this is a low pH.
Right.
Yeah. She was like right out a few times. That always helps. That helps me. I don't know.
No. And then I actually thought of something before. Like K is like the carbs, and then they make cookies because cookies have lots of carbs, and some beta sorority girls making cookies.
Sounds like a beta. Sounds like sorority, huh?
Yeah.
Beta. So beta cells are actually endocrine cells because they don't secrete anything into the duodenum. They secrete into the blood. And so carbs are also known as what? Sugars, right? And so eventually we're going to take this carb and we're going to absorb it through co-transport and sodium. Remember that? We're going to put it into the blood. Right? And once the carbs are in there, how do we get it from the blood into the cell? Into just a normal body cell. Because remember, the carbs are in the duodenum, so we're in the duodenum. Then it gets absorbed through a cell,
Yeah.
Through
and then-
co-transport, glucose and sodium.
Yeah.
Co-transport, secondary active transport into here, then goes into the blood. But then we have to put it into this cell over here to make ATP, right? That's our whole goal. Remember that 264?
Yeah.
Well, how do we go from the blood to the cell with
You
glucose?
do another.
You need a hormone. What's it called? If you're diabetic, you have a problem with this hormone.
Insulin.
Insulin, right? So K cells release GIP, which goes to the beta cells to tell the beta cells to release insulin. So beta cells are actually what release from the pancreas insulin.
Okay.
And then insulin puts this into there. So is insulin needed to absorb sugar from the GI tract?
No.
It's needed to absorb sugar from the blood into
Into
the
the
cells, right, to make ATP. So that's kind of a tricky question because we think it is, because it's released by K cells and GIP, but it's an endocrine releasing gland in there, right?
Yeah.
And that's why when they ground up pancreases and they try to inject it in people that were diabetic, because they were trying to give them insulin.
And it wasn't
But
working.
they didn't know that beta cells were next to the sine cells that have lipase, protease, and amylase. Well, insulin's a protein, and protease is going to break down insulin. So by the time they injected it, when they ground it up, they also mixed all those digestive enzymes, and they destroyed the insulin before they injected it.
Oh, sure.
So they have to do it. So people who have
That's why they
type
put
1
it in the
diabetes,
bloodstream rather than.
their immune system attacks beta cells.
Okay.
They can't produce insulin.
The immune system attacks the beta cells, which cannot produce insulin.
Which means they can't absorb sugars from the blood, which means they have a high blood sugar, which just builds up.
Okay.
Does that make sense?
So you have high. You're getting a phone call if you want to.
It's okay.
They have high blood sugar. So insulin essentially lowers your blood sugar and
Yes.
gets the sugar into your cells, which is just going to help you make ATP.
Yeah.
Okay.
Does that make sense?
Yeah.
Perfect.
Awesome.
Does that help you with that?
Yeah, it does. Okay. So inhibition of the exocrine pancreatic secretions would likely result in, well, so we said the exocrine ones are gonna be the ones that are gonna be the digestive enzymes.
So if you inhibited exocrine pancreatic secretions, would you decrease insulin?
No, because that's endocrine.
Would you decrease biosynthesis and secretion?
That doesn't have anything to do with it.
Because that is eye
That's-
cells,
yeah.
those are endocrine. Would you have an acidic chyme?
Yeah, because you're on remake, HCO3.
Perfect, right? Would you have increased protein absorption in the ileum?
Okay, wait.
Increased protein absorption.
Well,
What do you
yeah.
need for that?
Well, I'm just thinking about the acidic chyme thing.
Uh-huh.
The acidic chyme, like, that's the HCO3 that's going to be
Yeah.
stimulated
Well,
by
the
the S
acidic
cells.
chyme comes from the hydrogen proton pumps in there, right?
Yeah.
They come down, they activate S cells, and they go up there because those aren't
Yeah.
these aren't inhibited. It's the exocrines, right? So these guys go up and tell the liver to reduce. Or no, these guys go up to there, so they stop pumping. They go here, and they tell the sine cells, which are exocrine, to say pump out what HCO3 minus and hydrogen and water, right? So they pump that out into here, and they pump it out into there. But that means that's an exocrine. So if I'm inhibiting the sine cells, basically. So even though these are working, I'm not able to make my chyme more alkaline. It's going to stay acidic.
Yeah, which that makes sense except for the fact that the S cell is an endocrine cell.
But well, yeah. So this is going, but if the sine cells aren't working, you can be stimulating them all day, but they're not working because you inhibited those cells,
Okay.
and so they're not reacting to the secretin. So yeah, you can release secretin, but if the sine cells, which are the ones that release bicarb,
Yeah.
you're not going to release any bicarb anyway,
Okay.
right?
Yeah.
It's like if you put gas in your car, but your motor doesn't work, you're not going to go anywhere, even though you're putting gas in the car. You know? Does that make sense?
Yeah. No, that makes sense. It's like the second step to it.
Yeah.